Good morning to all. Now we are going to see about the topic of roots of cloud computing. The main major of the roots of cloud computing are mainframe to cloud, SOA, which is service oriented architecture, web services, website 2.0 and mashups. Then grid computing, utility computing, hardware virtualization, virtual appliances and OVF, then automatic computing. The convergence of various advances leading to the advent of cloud computing are split up into four parts. The first one is in hardware, second one is in internet technologies, third one is in system management, and the fourth one is in distributing computing. In the part of first one, hardware, this explains the hardware virtualizations and multi-core chips and how we can use the hardware along with the virtualization with some of the applications like VirtualBox while creating multiple OS or using multiple OS in single system like that. These are all comes under hardware part. Then second one is an internet technologies, how the applications services through the internet with the help of service oriented architecture and web services like HTTP request, HTTP response, and how the client requesting the service and how the server responds the request like that. These all comes under internet technologies. And the third one, system management. Here it how it can manage the traffic controls and how the data center may automating the informations from one server to another server, and how they are make use of auto scaling. These are all comes under system management. The final one is in distributed computing. This is a major part of utility computing and grid computing. Grid computing is mainly used by some of the rare applications, and utility computing also like that. The convergence of various advances leading to the advent of cloud computing. This model is mainly used for both the consumers and providers. Here, the providers means IT services. The consumer can contain a reduction on IT related costs by choosing either cheaper services from external providers as opposed to heavily investing on some of the IT structure, infrastructure, and personal hiring. And the final one is an on-demand self-service. Here, the on-demand component for this model allow the consumer to adapt their IT usages, which rapidly increasing or unpredictable computing needs. Then here the IT services can be provide some better operational costs for both the hardware and software infrastructures. They are mainly used to build multiple solutions and serve some of the users with increasing efficiency and return on investment, as well as low cost of ownership, which is an TCO. How it is explained from mainframe to cloud. The cloud computing delivered a utility process which demands on services. It delivers some of the infrastructures, applications for business purposes and also security rich. It can share the memories and it moves to scalability based on the environment over the internet environment. It is mainly advantage to both consumer and provider. The service oriented architecture. The service oriented architecture is a package which have mainly used for services. It is a well defined self contained modules that provide standard business functionality and also independent for state and context of other services also. In this consumer web, the information and services may be programmatically aggregated but acting as an building blocks of complex compositions called service mashups. Otherwise, we have in traditional method, the website is mainly used for just reading the information from the website. But now we have moved some of the advanced level, which is we can post our thoughts through the message or comments. We can like the post we can tag someone like that. The website is more developed or comes under Web 2.0 condition. In software as a service domain, the cloud application can be built as composition of some other services from the same or different providers. The services such user authentications or emails, payroll managements, and calendars are the best example for building blocks that can be reused and accompanied with business solutions in case of single or ready-made system does not provide all those features. Next, grid computing. The grid computing which enables aggregations of distributed resources and transparently access to them. The most production of grid computing is in TeraGrid and EGEE to seek to share compute and storage resources across different administrative domains. It is mainly focusing on to speeding up the range of applications such as climate modeling, drug designation, and protein analysis. The green computing is nothing but we can do the same task in multiple or physical machines or multiple computer systems. We have focusing on single task, but it can be done by many peoples with different systems. Next, utility computing. This utility computing environmentals where users assign a utility value to their jobs, where utility is fixed or time varying valuation that captures various quality of services constraints among deadline importance and some of the satisfaction of consumer and provider. Next one is in hardware virtualization. As I have mentioned in the previous of video, that hardware virtualization is nothing but we are using multiple OS in same machine or same physical system. For example, the cloud computing services are usually backed by large-scale data centers composed of thousands of computers. Such data centers are built to serve many users and host many disparate applications. This hardware virtualization allows running multiple operating system and software stacks on a single physical platform. The best example for this is an Oracle VirtualBox. See, here is the diagrammatic representation of hardware virtualized server. The first one is an virtual machine 1, virtual machine 2, and we can use n number of virtual machines. While creating this virtual machine, we have just inserted some other OSs in this machine and push it out through some of the applications and NAT network. First, it is an bottom-up approach. First is in hardware. Second is in virtual machine monitor, which is hypervisor. The hypervisor is differentiated into two types. One is an embedded hypervisor. Another one is an hot hypervisor. Then we can mention the OSS types, Linux, Windows. Then another part is an database or web servers, what you can need. Then what are the applications comes under. These are all the complete containers of virtual machines. A number of virtual machine platforms can exist that are the basis of many utility or cloud computing environments. The best examples are VMware, Zen, and KVM. Last class we have see about layers and types of clouds. Now we are going to see about service models. The service models can be split up into major three types. The first one is an infrastructure as a service, second one is an platform as a service, and third one is an software as a service. Infrastructure is nothing but we are using the infrastructure as a major platform. For example, cloud clients which have used web browsers, mobile applications, then terminal emulators like that. The basic services users can maintain here the software. Next, the platform as a service. Here the user can given software and hardware automatically. Just we have pull up user the application. For example, execution runtime, database, web servers, development tools like that. Final one is in software as a services. Here they have already developed some of the softwares which some required cloud platform. For example, um, Google Drive. It is a cloud-based application. Here we can store the application on the cloud. Comes under service provider as Google Cloud. The cloud computing stack. The first one is in service classes SaaS, PaaS, and IaaS. The second one, main access and management tools, which is web browser. The second one is in cloud development environment, and third one is in virtual infrastructure management. The final one is in what are the services they have contained. First one, SaaS, which is in software as application. This comes under cloud applications as cloud networks, office shoots, CRM, video processing, like that. Then what are the cloud platforms? Mean programming languages, frameworks, mashup editors, structured data, like that. The final one is in cloud infrastructure. Here we can compute services, data storage, then load balancer, firewall, etc. What does mean by infrastructure as a service? Here we are mainly offering some of the virtualized resources. The virtualized resources mentions computation, storage, and communications with on-demand services known as infrastructure as a service. A cloud infrastructure enables on-demand provisioning of servers running several choices of operating systems and customized software stacks. The infrastructure services are considered to be a bottom layer of cloud computing systems. For example, AWS. Here it provides some of the storage applications and computations and network securities like that. Some of the tools like EC2 and S3. Main features of infrastructure as a services are it is a service oriented utility computing, automation of administrative tasks, unlimited resources, pay per use pricing, desktop virtualization, policy based services, on demand self services. Then second one is in platform as a service. It is a higher level of abstractions to make cloud easily programmable is known as platform as a service. A platform as a service which offers an environment or on which the developers can create and deploy applications and do not necessarily need to know how many processors or how which memory that applications will be using. For example, if we are logging in the AWS account or if we are creating AWS account, we have just using the free resources like EC2 and S3. We doesn't buy full platform. So whatever the services you need, you can pay and you can use in that AWS platform. Such type of examples comes under platform as a service, where the service provider already created the platform to deploy the applications. The users can just buy and implement their applications through the cloud platform. It is in building blocks of memory objects such as cache, mail services, instant messaging services, XMPP, and image manipulation services, and integration with Google accounts with authentication services. The main example of PaaS is Google App Engine. It is an example of platform as a service which offers a scalable environment for developing and hosting a web applications, and it also used to return some programming languages such as Python, Java, and some other languages with their uses, and it uses own proprietary structured object data for storage. The merits of platform as a service is it is mainly possibility to change and upgrade the characteristics and components of operating systems. It is easier collaboration with specialized over the world. And the final one is it is an overall cost reduction by minimizing the expenses of hardware and programming tools to avoid incompatibility problems. The demerits of platform as a service is some providers may not allow to develop software out of the platform. The flexibility of the services may be still insufficient during some of the meetings, the needs of users who requires some constant changes. Then the final one is in software as a service. Here, the model can allow the user to provide software application as a service to the end users. It refers to the software that is deployed on host services and is accessible via through or internet. These services provided by this layer can be accessed by end users through some web portals. Some of these SaaS applications are billing and invoicing systems, CRM, which is customer relationship management applications, help desk applications, human resource solutions, like that. What are the main characteristics of SaaS? It is mainly used for vendors. It makes software available over the internet. The license of the software may be subscription based or usage based, which is an on-demand self-servicing. The applications are most cost effective and they do not require any maintenance at the end side users. They are available on demand. They can be scaled up or down on basis on the demand. They are automatically upgraded and updated. Here it shares the data model. The multiple users can share a single instance of infrastructures with hard code of functionality to individual users. All users can run the same version of the software. What are the benefits of software as application? The first one is an modest software tools. The second one is an efficient use of software licenses. And the third one is an centralized management and data. The fourth one is an platform responsibilities managed by some providers. And the fifth one is an multi-tenant solutions. The major issues of software as a services comes under browser-based risks, network dependence, lack of portability between SaaS clouds. The first diagram can be explained how the cloud applications is used based on some of the service models SaaS, PaaS, IaaS. The short summary of these three are: the first one is in software as a service. Here they have already used particular cloud platform and they can develop the application based on cloud servers, cloud services or cloud providers. For example, Gmail, Google Drive. Here the applications are developed by Google to store some of the files, images or videos of the particular user account. The software is already developed by cloud provider. The user just using that the software. The second one is in platform as a service. Here we can deploy the applications based on some of the platforms. For example, in AWS, the two tools we have using, one is an EC2, another one is an S3. Here we can deploy the application on the two tools. The two tools are free to use while creating the AWS account at free of cost. We can, if we are developing some of the Python application or Java application, we doesn't need to install any environments or platforms to run the application. We can just push the application into the tool and just deploy the applications. Then final one is an infrastructure as a service. Here we can just share the network resources, storage and accessibilities. Then how the data can be load their balancing and computing servers across multiple infrastructure manager. This infrastructure as a service comes under virtual machine migrations. We can share the memory or we can share the data storage with some other cloud platforms like Google Cloud App Engine, Amazon AWS, otherwise Microsoft Azure. That's all about today's class. Thank you.